Hey too, thanks for visiting. Hope all you are doing well. So we meet after a long. In the last video or in the last class, we discussed the Bessel functions of first kind. Okay. So in the previous video, we already discussed this thing, and in this video, some topics of Bessel functions and the second kind of Bessel's functions basically remaining in today's we discuss in today's class. Okay. So let's start, and before starting, I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and don't forget to subscribe the channel. Okay. So let's start with Bessel functions of second kind. So before going to the Bessel functions of second kind, I just remind you the Bessel functions. So what is the Bessel functions? So the differential equation is the type, each of the type x square y double dash minus x y dash plus x square minus n square into y, this is equal to 0. This is known as the Bessel differential equation, and we already discussed the Bessel functions of first kind is generated by j and x. Okay, so I am not going to the j and x part today's video. Okay, so the Bessel function of second kind is basically defined by denoted by y n x, capital Y n x, and is defined by j n x cos n pi minus j minus n x by sin n pi, where n is not an integer. And in case of n is an integer, then limit v then another variable tends to n j vx cos v pi minus j minus bx by sin v pi. So this is the Bessel functions of second kind, which is denoted by y n x and defined by this one, and which is actually dependent on the Bessel first function, Bessel functions of first kind. Okay, now the general solution of the given differential equation, that is the Bessel differential equation, is denoted by this one, y equal to a j n x plus b j minus n x, where a and b are arbitrary constant. And so this is the first kind, okay, in the form of first kind. And in the form of second kind, we just write y equal to a j n x plus b into y n x, where n is not an integer, n is an integer. Okay, so where n is not an integer case, we write the Bessel functions of first kind, and in case if n is an integer, then we write Bessel functions of, or we can introduce the Bessel functions of second kind. Okay, now one more important thing. So see, in the videos I am not going to the deeper part or the proof part of the these results. Okay, I just going through and going through an upper versions or light versions of the not deeper part, so that you can just answer the questions in the competitive exams like GATE and engineering mathematics and SES and NET. and सो सेस एंड नेट में तो नहीं आता है, ठीक है, तो गेट में आता है बेसल फंक्शन, एंड वो कोई कोई जो इंजीनियरिंग का एग्जाम्स होता है वहाँ पर आता है, ठीक है. तो आई एम नॉट गोइंग टू द प्रूफ पार्ट. ओके, सो सी द नेक्स्ट important thing is the generating function for the Bessel function. Okay, so the generating function is defined by expectation of half x into z into 1 minus z. This is known as the generating function, and if we write as in the form of series, then we can write n equal to minus infinity to infinity z to the power n and j n x. Okay, so this is equal to, we can write j0 plus z minus 1 by z into j1 plus z square plus 1 by z square into j2 plus z cube minus 1 by z cube into j3 plus, and so on. There are infinite number of terms. So this is the generating function. Now integration of the Bessel differential or Bessel functions. Okay, so for n greater or equal to minus 1, we can write integration 0 to 1 x to the power n plus 1 j n x is equal to x to the power n plus 1 into j n plus 1 x. I think this is not 0 to 1, this will be 0 to x. Okay, so this is the Bessel differential Bessel's integration. Now there are some trigonometric expansions involving the Bessel function. So these trigonometric expansions are very important for your exam point of view. Okay, so I am not again going to the proof part of this trigonometric expansion. You can just learn that these trigonometric expansions comes from the generating function. Okay, so from the generating function we can construct this all trigonometric expansions. Okay, so first number one is cos of x sin pi. So this is equal to j0 plus 2 cos pi cos 2 phi into j2 plus 2 cos 4 pi j4 plus so on. Number two is sin of x sin pi. So this is equal to 2 sin pi j1 plus 2 sin 3 pi j2 plus so on. So see, these cos and sin series are like sine and normal sine and cos series, okay, you can say. But there is the series expansion is different obviously. Number 3 is cos of x cos phi. So this is equal to j0 minus 2 cos 2 pi j2 plus 2 cos 4 pi j4 minus so on. Number 4 is sine of x cos phi. This is equal to 2 cos phi into j1 minus 2 cos 3 pi into j3 plus 2 cos 5 pi into j5. So plus minus alternative sign and j1 j3 j5. Okay, now simply cos x is equal to j0 minus 2j2 plus 2j4 minus and so on. So this is equal to, you can write j0 plus summation 2 summation n equal to 1 to infinity minus 1 to the power n into j to nx. Okay, and simple sin x is equal to 2j1 minus 2j3 plus 2j5 and so on. So this is equal to, you can simply write 2 summation n equal to 0 to infinity minus 1 to the power n j to n plus 1 into x. Now we see some examples. So first we see this example. This is based on genetic function and this comes in GATE 2015. Okay, so if for let expectation of x by 2 into t minus 1 by t equal to this, so this is given you that the trigonometric genetic function and the series expansion form for all t greater than 0 and x belongs to R, the value of this one. Okay, so see the value of j 0 pi by 3 plus 2 n equal to 1 to infinity j 2n pi by 3. So see j 2n pi by 3. So why, how can you solve this type of problems? Okay, so when this type of problems comes in the exam, you always think the trigonometric expansion of the Bessel's function. Okay, so here you have to consider one of those 6 obviously the trigonometric expansion. So first you can discard sin x and cos x, because in the sin x and cos x there is I think no term regarding this, I think, yeah. Okay, so we can write cos of x sin pi. This is equal to the expansion number cos of x sin phi, the first expansion. Okay, so cos of x sin phi equal to j0x plus 2 cos 2 pi j2x plus 2 cos 4 pi j5 4x and so on. Okay, so see I think yeah, see here only j2n term present and only plus term present. So okay, so that you can consider one of those trigonometric expansion which cover all the positive terms, no negative term present. Okay, but here the expansion gives you the negative terms also, but here you have to find the value in which so there are no negative terms including this summation. Okay, so we consider this one, so that this does not consider any negative terms. Okay, so now we can just put the phi equal to 0 and x equal to pi by 3, okay, to get this required value. Okay, so a cos 4 phi means, so this terms goes to j0 pi by 3 plus 2 j2 pi by 3 plus 2 j4 pi by 3 and so on. This is equal to the left side term is phi equal to 0 means this goes to cos 0 and cos 0 is equal to 1. Okay, so this we can write j0 pi by 3 plus these all terms we can write in the summation form. So n equal to 1 to infinity, 2 is the outside of the summation, this is equal to j 2n pi by 3. Okay, and we have to find this value obviously. So this is equal to clearly 1. So the answer is here 1. So this is very good problem, comes in GATE 2015. Okay, now this is also a problem of GATE exam. It says that integration 0 to x x cube j0x dx, this is equal to x cube j1x minus 2x square j2x. Okay, and number 2 is here present. Okay, so this is the expansion form of this, you can say, or in general form. This is the general form, the first one is general form and second one is special form, you can say. Okay, so we know, देखो इंटीग्रेशन आप जो यहाँ पर जो गिवन है इंटीग्रेशन, इसका इंटीग्रेशन ना जानो तो भी ये क्वेश्चंस हो जाएगा, क्योंकि हम जानते हैं कि जो डेरिवेटिव एंड इंटीग्रेशन हो मतलब क्या है, एंटी है, ठीक है, मतलब डेरिवेटिव इज एंटी फॉर्म ऑफ इंटीग्रेशन और इंटीग्रेशन इज एंटी फॉर्म ऑफ डेरिवेटिव, यू कैन से. So ddx of this one is equal to this one, so we can write obviously integration x to the power n jn minus 1x dx, this is equal to x to the power n. So if we integrate this term, then we get this term obviously, so x to the power n jnx. Okay, so now here we have to find the 0 to x into x to the power x cube into j0x dx. So this is equal to integration 0 to x x square into x j0x dx. Why? Because we can do this derivative part, so that we can apply here the by parts, integrating by parts formula. Okay, so this is equal to, this is the first function, so x square into this is the first function. Okay, integration of this one, x j0 x, this is equal to x to the power n into j n minus 1 x. So this is x into j1 x, and integration from 0 to x, and minus ddx of this term and integration of this term. Okay, so this is integration second types. Okay, so integrating by parts, we can write here x cube j1x, since this is x1 x cube j1x, upper limit minus lower limit, and 0 means gives 0 since here x term is present. Okay, minus 2 into integration 0 to x square into j1x dx. Now we can again use this above formula here, so we can write x cube j1x minus 2 into x square j2x 0 to x. Okay, so simply the above integration formula, so we can write integration 0 to x x cube into j0x dx is equal to x cube j1x minus 2x square j2x and plus 0. So this is the lower limit is 0 since x square is present. Okay, so this is the required result we have to prove. Okay, now the second part is integration 0 to 1. So we can just put x equal to 1 here in the integration or in the upper limit. Okay, now if we put x equal to 1, then we get integration 0 to 1 x cube into j0x dx. This is equal to j1x j1 1 minus 2 j2 1. So from directly this result. Okay, now here no term in j2 is present in this right side. Okay, so we have to discard, or we have to replace j2 by any other Bessel functions. So we consider here the recurrence relation jn minus 1x plus jn plus 1x equal to 2n by x jnx. So now we can put just n equal to 1 and x equal to 1 for this. So this is the n and this is the x. So we can put n equal to 1. So we get n minus 1 means 1 and 2, and here 1. Okay, so 0 1 and 2 we get. Okay, so we have to put the value of n such that these values of j's are not exceeding the maximum value in this suffix. Okay, so j2 1 plus j3 1, this is equal to 2j1 1, and since here the term of j3 is present in the proof of this problem, so we can using put this n equal to 1 and x equal to 1. Okay, so this gives j2 1 is equal to 2j1 1 minus j3 of 1. So we just put the value of j2 in this result. So integration x cube into j0x dx is equal to j1 1 minus 2 into this is the value of j2. So we can get the required result 2j01 plus minus 3j1 1. Okay, so I think this video is helpful. So this is a very shortcut video. Okay, I am not going to the deeper section of this part again, I say, because this is very shortcut for revise for a point of exam point of view. Okay, so if the video is helpful, then obviously do comments in the comment section below, and you like to this video, share with your friends, and obviously consider subscribing to my channel. Okay, thank you, bye, मिलते हैं अगला वीडियो में.